section 2, we're going to be talking about the fundamental laws of algebra, operations on positive and negative numbers, order of operations, and lastly, operations with zero. So, first, our fundamental laws of algebra. Now, maybe you forgot what these are, but I'm here to review them with you. And they're actually very simple, so we're going to go through them kind of quickly. All right? So we're going to be using literal numbers to show or demonstrate these laws along with a little example. So the first are the commutative laws. Okay? Now you do have two of them. You have the commutative law for addition and multiplication. And here's what they are right here. So the literal numbers are a plus b equals b plus a, which means the order doesn't matter in which you add things. So underneath in red, how about 3 plus 5? Well, that's going to be 8. But what if you reverse the order, 5 plus 3? Well, you still get 8. So that's perfect. Here's our law. Nice little example. Same thing with multiplication. A times b is equal to b times a. So we're going to use the same numbers. 3 times 5, well, that's going to be 15. And if I reverse the orders, 5 times 3 is still 15. So there are the commutative laws. Now, the next laws we have are the associative laws. Oh, misspelled it. Hold on, misspelled it. A-S-S-O-C-I-A-T-I-V-E. I guess I did spell it right the first time. Oh, well. So we have the associative law, and once again, you have them for addition and multiplication. And the associative laws deal with grouping. Like, how do we group things? So, for example, if we want to add, let's say, a plus b plus c, we could group b plus c first and then add a. And that's going to be the same exact thing as if you grouped a plus b first, but then you added c afterwards. So here's our example. Let's say we grouped 3 plus 4 first, and then we added 2. Well, that's going to give me 2 plus 7, and 2 plus 7 is 9. Now that should be the same as if we grouped the 2 plus 3 first, and then added the 4 afterwards. Well, if you think about it, 2 plus 3 is 5, and 5 plus 4 is also 9. For multiplication, basically the same exact idea, right? We group B and C, but then we multiply A. And then the other side would be grouping A and B, and then multiplying C. So let's go ahead, let's do an example. So let's multiply 3 times 4 first. Well, that's going to give me 12. And then and then 2 times 12 is 24. Now, if I did this the other way, let's say we group 2 times 3, then we multiplied it by 4. Well, 2 times 3 is 6. And 6 times 4 is still 24. So, those are the associative laws. And then the last law that we have actually relates multiplication and addition, which is our distributive law. And the distributive law says if you have a number outside of a group, and within that group you have like multiple terms, okay, like b plus c, you can distribute that letter A to every single term inside of the parentheses. So an example of this would be something like 2 times the quantity 3 plus 5. if we did 3 plus 5 first, you get 15. I'm sorry. If you do 3 plus 5 first, you get 8. Don't kill me in the comments. You get 8. And then 2 times 8 is 16. Now, what if we distributed the 2 first? And then we did our multiplications. 2 times 3 is 6. 2 times 5 is 10. Notice that you get 6 plus 10, which is still 16. So this is a review of the fundamental laws of algebra. The next thing we're going to go over, did I put a 1 in front of it? Yeah. Okay, good. Sorry. The next thing we're going to talk about are the operations on positive and negative numbers. So whenever you see this word, operations, you should be thinking add, subtract, multiply, and divide. Okay? We're going to do multiply and divide first. They're the easy ones. We'll loop back and do add, subtract. So when we go ahead and we multiply or divide integers. Now remember, integers are positive or negative whole numbers, all right? We can use this nice table here. So A and B represent any numbers you want, but what we're really concerned with are the signs. So if the first number is positive, the second number is positive, your result is going to be positive, whether you are multiplying or dividing. Doesn't matter. If the first number is positive, second number is negative, your answer will be negative. If your first number is negative, your second number is positive, your result's going to be negative. And finally, if your first number is negative and your second number is negative, the result is going to be positive. So a negative divided by a negative is a positive. All right? So that is the really simple part for the multiplying or divide. It's the add or subtract that a lot of us have issues with. And what I mean by a lot of us, what I mean is like when you're learning this initially. So when you add or subtract integers, we basically have 2 rules that we're going to follow, okay? And both of these rules they involve this absolute value somehow, okay? So the first rule is when the signs of the numbers are the same. Okay? So when the signs of the numbers are both the same, and I think it's easiest just to show you an example. How about 10 plus 15? Well, if you think about a number line, if you're at 10, okay, and you add 15, notice that you're moving in the right direction because you're increasing that value. So 10 plus 15 obviously is 25. And the reason, because you're starting at 10 and you're moving 15 units to the right. So when the signs of the numbers are the same, you add the numbers and you keep the signs. So that's why 10 plus 15 is positive 25. On the other side of this, let's say we wanted to add -10 plus -15, okay? Well, if you think about this, once again, you're standing at negative 10, but you're moving this direction. Now you're moving more negative. So negative 10 plus 15. Once again, though, the signs are the same. You add the numbers and you keep the sign. All right? So that's the most important part. The other thing I want to go over real fast is sometimes, and I'm going to zoom in for us. So sometimes when we see two signs back to back, okay, you want to go back to that chart that I gave you earlier, all right? You have a plus and a minus back to back. If you think about that in terms of multiplication, a positive and a negative make a negative. So really, another way that you can write this problem is negative 10 minus 15. But if you think about it, once again, you're standing at negative 10, and then you're moving 15 units to the left. So signs are the same. Add the numbers, keep the sign. The other rule that we have, which is our second rule here, all right, this deals with when the signs of the numbers are opposite. All right, so an example of this, to keep the numbers nice and small, would be something like negative 2 plus 6. Okay? Now, visually, this is really easy to see. All right? So visually, here's what's happening. You were starting at negative 2, but that plus sign says, hey, go to the right. And it's going to tell you go to the right 6 units. So 1, 2, 3, 4, 5, 6 units. So when you look at this, negative 2 plus 6 is positive 4. But not everything can be nice and neat where you can just instantly draw a number line real fast and call it a day. All right? So here's what's really happening. All right? When the signs of the numbers are opposite, and even if you already know how to do this, you're doing these 3 steps so fast in your head that you don't even realize it. So when the signs of the numbers are opposite, here's what you're really doing. The first thing you're doing, actually, let's write it as A. The first thing you're doing is you are actually taking the absolute value of each number. Negative 2, the absolute value of it, negative 2 is positive 2. The absolute value of 6 is 6. And you're noticing that the 6 is the longer distance from 0. Which means our answer will be positive. All right? The second thing that you did real fast in your head, the second thing is you said, okay, since 6 is the longer distance from 0, I'm just going to subtract the 2 numbers. I'm going to put the larger or the longer distance on top, and I'm going to subtract the smaller distance from it. That's what you did. And then the third thing you did was you said, I'm gonna give you ownership. My answer is positive because 6 was the larger absolute. So if I zoom out here real quick, just to kind of get everything in one screen, this is what you were actually doing. It's just you did it so fast because negative 2 plus 6, you can do that in your head real quickly. But it really takes advantage. This method is really nice when you have something like oops, sorry. When you have something like negative 341 plus 898. All right. So for this problem right here, a number line is it's just not good. So let's go ahead. Let's do this real fast. First, we're going to find the absolute value of each. In red, the 898 is going to be the larger distance. Okay. Part B, since you know the 898 is the larger distance and you know your answer is going to be positive because of that, we're going to subtract these two numbers, 753. So our answer is 357. Okay? Now, the next thing I'm going to go over, this is the biggie. It's the order of operations. Now, I know you've heard it before as, I don't know, PEMDAS or please excuse my dear Aunt Sally stuff. But I'm going to ask you to get away from that. Okay? The reason why is in this example right here. This is one of those this is one of those problems you always see like on Twitter or Instagram or TikTok or something like that. Which is 12 divided by 6 times 2. Now, a lot of students, I don't want to say a lot. I don't want to say a lot. That's bad words. Let's say some. Some students would look at this and say, the answer is 1. And unfortunately, it's incorrect. This answer is 4. But let's explore why, okay? And then we'll come back to this. The way that I like to write the order of operations is like this. I like to write it as a hierarchy of system. So P is up top, A/S down at the bottom. And the reason is P, I know it stands for parentheses, all right? You always want to do all your work inside of the parentheses, all right? But in reality, what we're really talking about here are grouping symbols, okay? You want to do all your work inside of the grouping symbols. And what are grouping symbols? Parentheses, brackets, and braces, okay? So you do all the math work inside of those groups first. Then we deal with exponents. All right? After that, this is where the multiplication division thing comes in. And students, for some reason, sometimes think multiplication comes first. And the answer is no, that's actually false. You do them, so you do these operations, so you do them in order from left to right. All right? And the same thing applies to addition and subtraction. You do them in order from left to right. Therefore, this problem I had on the board earlier, 12 divided by 6 times 2. Well, if you go through your order of operations, multiplication, division, you do them in order from left to right. We actually do the division first. 12 divided by 6 is 2. And then you do the multiplication second. 2 times 2 is 4. All right? So what I'd like to do here is just go over a couple examples real fast. Nothing too crazy. All right? So we're going to do 2 times negative 3 minus the quantity of 4 minus 8. All right? So remember, parentheses first. I'm going to rewrite everything exactly the same, except 4 minus 8 is negative 4. Next, going from left to right, I'm going to do exponents. I don't see any. Going from left to right, multiplication or division in the order they appear. I'm not going to do too many things at once. I'm going to keep it nice and straight. So 2 times negative 3 is going to be negative 6. And now, I know a lot of you, we see the two signs back to back. Use your table. When you have a negative and a negative back to back, it makes it positive. And finally, negative 6 plus 4 is negative 2. All right? The next example we're going to go over deals with operations with 0. All right, so once again, this is one of those things where you see operations, you should be thinking add, subtract, multiply, divide. So the literal numbers, a plus 0 equals a. Example, 2 plus 0 equals 2. A minus 0 also equals a. Example, 2 minus 0 equals 2. Next, a times 0 equals 0. So an example would be 2 times 0 equals 2. Oh, sorry. 2 times 0 equals 0. I'm laughing over here. But all three of these were really straightforward. It's the last one you got to worry about. All right? 0 divided by a is the same exact thing as saying the fraction 0 over a, which equals 0, provided a itself is not equal to 0. All right? So the example would be 0 divided by 2 equals 0. All right? But I think we need to investigate this a little bit more. And the reason is I want to make sure you see why this works out the way it does. So let's go back to that fraction. Let's say we have 0 divided by 2. Visually, let's do this. You could draw a rectangle, cut it up into 2 pieces, and nothing is shaded. So that's why it's 0. But if you think about it the other way, 2 divided by 0, what you're telling me here is this rectangle, it doesn't exist. The rectangle was not there. So how in the world can you shade 2 pieces of it if there's no rectangle to begin with? So what we say is 2 divided by 0 is undefined. Okay? It's undefined. Can't do it. All right? So this is the thing you got to remember. A number divided by 0. Look what it spells. N-O. No, you can't do that. That is undefined. Okay? And that's going to be it for this section. I'll see you in the next one.